just to make sure everyone's in the right place, this is AppDev 201, DevOps for application developers. I'm Aja. I'm not going to have a lot of time after the talk for questions. I thought I would, but there's too much content to share with you guys today. So if you have questions, I encourage you to tweet them at me. I am _Thagamizer, which is the spiky part at the end of a stegosaurus. And I have my DMs open if you don't want to share your question publicly. I will try to get to them tonight at some point. I'm sorry I can't do questions live. So who's this talk for? So this talk is for folks who have an MVP. You've got something that's super cool. You think it's going to be the next giant thing. But you have no idea how to get it to production in a safe and stable way. Or maybe you're new to GCP. This event got a lot bigger this year, so I'm assuming that some of you are new, maybe. Maybe you're one of those people who just wants a well-worn path to follow. When I was doing consulting, we had one way that we shipped most of our web apps because we knew it worked, we knew how to do it right. And so we used it as much as we could. It was our well-worn path. So I'm going to try to give you some ideas of some well-worn paths on GCP. And this talk is especially for folks with minimal DevOps experience who want to know just enough that they can make cool things and make them available for other people to use them. So what's this talk about? The title is decidedly vague. This talk is about productionizing an application. We're going to talk about your compute options on GCP. We're going to talk about monitoring, application performance monitoring specifically. And then at the very end, there's going to be a recap. We're going to give all the information again so that you can see it twice. And the AV team has been really good about getting the talks up on YouTube very, very quickly. So you don't feel like you have to take notes. You will likely be able to see this again at your own pace tomorrow. And so I'm going to do something a little different here. Every time I've given a talk like this in the past, I've been like, this is one of your compute options. This is what it's good at. This is what it's not good at. But that didn't really work for me with the narrative flow. I found it really boring, and it didn't actually help folks make good decisions. So I flipped that on its head for this talk. And the entire talk is going to be based around questions. I have 7 questions that I think everyone should ask themselves if they're taking an app to production. And they're not yes or no questions, so they're going to make you think a little bit. I hope to eventually do a blog series about these questions, because there's a lot more that I'd like to cover that I can't get to in the time allowed. So please bear with me if the format doesn't work for your brain. Hopefully for some of you it works better than the standard format. It works really well for me. So question number 1. Question number 1 is, what are my priorities? If you're shipping something, you have priorities. And priorities are super important because everything in the DevOps/SRE world is a trade-off. The most secure, bug-free website is one that doesn't exist and doesn't have any users and was never published. And none of us want that. So you're going to have some downtime, probably. Maybe not a lot, maybe only milliseconds every year, but you're going to probably have some downtime. You're going to have to make some sacrifices of how fast you can move for robustness, or maybe how much you're willing to spend for how easy to use your application platform is. So you need to think about your priorities. Some examples of priorities is maybe you're very early stage, and you're demoing to potential investors. OK, there's a different set of priorities for that than if you're in beta testing or early access, or maybe even ready to go live. Maybe your biggest priority is saving money. No shame. No shame in saving money. I have worked at a startup. I have worked at a startup that nearly ran out of money. I get it. But you have to make sure that you're aware of the fact that that's your priority, so you make decisions with that in mind. Or maybe your priority is robustness. Maybe you are working on something where any downtime is going to be a problem. Well, you're going to make some decisions that are based on that, and they're going to have other consequences elsewhere. So think really hard about what your priorities are. Make sure you put them in some sort of approximate stack-ranked order, because those priorities are going to influence your choices. Your compute environment, well, some compute environments are cheaper. Generally, not always true, but frequently, more managed solutions are slightly more expensive than less managed solutions. But you're sacrificing time. Maybe that's the right trade-off for you. If you need a lot of robustness, maybe you need a lot of monitoring. If you mostly don't care, maybe you don't. If you're early stage, perhaps that's all you need. Maybe you work in an industry that has stringent audit logging requirements. Well, logging is going to be a priority for you. Maybe you don't write particularly good code like me, or you're jamming this out at the last minute, and so there's going to be problems in production. So being able to debug or trace and figure out what you did that's making everything explode, like my demo downstairs did yesterday, is important. And maybe you need disaster recovery. This is something that nobody thinks of until something goes wrong, like there's an outage. And then you're like, oh, right, that's the thing that, yeah, I was supposed to do that. So make sure you think about that up front. A lot of places don't need it, especially early on. But you might get to a point where you do. So that was question 1, priorities. Nothing actually technical there. We're going to get slightly more technical as we go on. Second question is, what does my load look like? So I've worked at a bunch of different places. I've probably had every job title that's common in tech at this point. And I had a company where I worked at where we only got load during the school day because we were an education product. So weekends, no use. Midnight, no use. 9 to 3, lots of use. So we had different load requirements than an app that has a pretty steady use case, or an app that might have special work it does late at night to do a bunch of computations or a bunch of predictive modeling. I worked at this website once where we were doing a release, and we had done a green-blue type deployment. We didn't call it that back then, because I've been doing this for a while. And we realized that 9 a.m. on Saturdays was our highest load we ever got during the week, and that's when we were trying to bring the site back up. And half of the cluster was not actually sufficient to support the entire load, so we went down. So that was a good lesson for us to learn about load, also a good lesson for us to learn about headspace. But you need to think about what your load looks like. And this is a question you should be asking yourself on a somewhat regular basis. Depending on how fast you're growing, it could be quarterly, it could be yearly, but you need to be thinking about what your load looks like, because that's going to influence your technology choices. So your load is going to influence your choices, I just said that. If you have a very variable load, so something that's a lot during some periods and none at all during others, sinusoid type thing, you're going to probably want something that's auto-scaling. On GCP, we have lots of those. We have App Engine, which is the one that most people know, been around for a really long time, 10 years. We have Google Kubernetes Engine, which also auto-scales. I'm using that for one of the installations downstairs in the showcase floor. People don't frequently know that Google Compute Engine will also auto-scale. You can set up managed instance groups on Google Compute Engine and say, it should be something between here and here. And it will auto-scale those for you. It will make more as you need them, take them down as you don't. And my new favoriteest thing ever, Google Cloud Functions, also auto-scales because it's functions as a service, and that's kind of what it does. It does units of work, and you can do lots of them or very few of them, and it's great. If you have periods of time where you don't want your website up, or your website probably doesn't need to be up, like if you're in that still really early on investor stage where you're only going to give them access for a couple days, scaling to 0 is likely important. So if you're going to need to scale to 0, your choices are App Engine Standard or Google Cloud Functions. Lots of people don't actually need to scale to 0, but if you need it, it's a fantastic way to save money. So if money is a priority, you might consider that as well. And then if you're setting up auto-scaling, you need to put bumpers. You need to say, this is the minimum size, this is the maximum size. And to do that, you have to know approximately how big your cluster might need to get. That's why we need to know about how many users we're going to have on a regular basis. The factor I've always used in my professional career, and I don't know if this is endorsed by any Google SRE, because I am not a Google SRE, is 2x of the worst case scenario. Now, there is a case study on our blog where 5x of the worst case scenario was not actually sufficient. So know your use, know how stuff's going to grow. I have had an app that went on a morning TV show in the US, and we way over provisioned for that. We actually kicked it up to 4x just in case it went really, really well. And the nice thing about auto-scaling stuff is you can say, OK, just for this day, because we know we're going to have this news article, let's put that top upper limit really, really high so we'll be OK if something goes awesome, but we don't have to pay for the extra awesome if things don't go so well. So be aware. You need to, again, reevaluate this on a regular basis. You can set those bumpers in appropriate places. Question 3, halfway through. There's 7 questions. I don't think I mentioned that. What skills do I have? So this is where you think deep inside yourself and like, what do I actually know? Specifically, languages and frameworks. I'm a giant language dork. If you go to my Twitter profile or you look at my conference bio, I mentioned Prolog because I am a giant language dork. But at GCP, I'm on the advocacy team, and one of my primary areas of advocacy is Ruby. So, very different. If I was going to have to do a database-backed website right now, I would pick up Rails. I know it backwards, forwards, and inside out. I know that I can get something up and running very, very quickly. But that's not the best solution for a lot of things. Doing WebSockets in Rails until very recently was awful, like truly, truly awful. So if I was going to do WebSockets, I would have picked up something like Node.js. I also have been using Node a lot because I've been falling deeply in love with Cloud Functions, and Cloud Functions supports Node. So think about what you know. If you're doing data science, Python might be a good choice. Think about what you're comfortable with. Also think about what kinds of configurations are you used to. So I've been asking this question at all the conference talks I've been doing of late because it's confusing me deeply. Who here has stood up a VM in a cloud or like actually physically like something they racked? Like made a VM, provisioned it. Okay. It's less than I expected, but still good. Who's taken that VM to production? Okay. So if I asked that question 5 years ago, it would have been the vast majority of the audience. And now that we're in this wonderful age of serverless and managed services, it's declining very steadily over time. No shame in having not done that, by the way. But if you've never done it and you don't want to learn it, probably Compute Engine is not your choice. You can also decide to learn stuff. You have to make sure you budget extra time. You have to make sure that you have resources available, meetups, whatever, to learn things. Make sure you're making that choice on purpose. I've been helping a number of folks over the last 2 years who are like, everyone says I should use containers. And I'm like, containers are awesome. And they're like, this is my first web application. I don't know what a stack trace is. And I'm like, containers are not your good choice right now. Let's do something else. Because you shouldn't be using containers unless you're comfortable enough with your stack that you can deal with the fact that the container adds an extra layer of indirection that makes everything just slightly harder if you're debugging application code. It makes a lot of stuff easier. It's a good way to make sure you're getting the most bang for your buck out of your infrastructure, but it makes some things harder, and you should make sure you go into that with your eyes open. Just because everyone else says containers are awesome does not mean containers are awesome for you. Just because everyone else says serverless is awesome does not mean that serverless is awesome for you. If you went to my colleague Brian Dorsey's talk about where do I run my stuff earlier, there was a giant slide that said it depends, and that's because it depends. There is not one best way. That's the thesis of this talk. That's what we're going to be talking about the entire time. So we have some language restrictions with our compute offerings. I wish we didn't, because my language is not particularly well represented, but we are adding more languages and more support all the time, and it is getting better. It is so much better than it was 3.5 years ago when I started at GCP. So Google Cloud Functions runs Node. More languages are coming soon. I cannot define what soon is. I am sorry. And when they come soon, they will be in beta. And I'm here to tell you right now, you should not use beta products in production. Please don't. It's a really bad idea. I don't feel like I should have to say that, but people do it all the time because they're super excited, and then it explodes, or we massively change the interface or something. So don't use beta products in production, pretty please. We have App Engine Standard, which supports Java, Python, Go, and Node is now in beta. So again, don't use beta products in production, please. But hopefully it'll be going GA relatively soon. App Engine Standard is amazing, but there are some restrictions on the libraries that you can use. And both Google Cloud Functions and App Engine Standard don't let you write to disk. It's becoming less of an issue recently, but for a long time, people were like, well, I have to write to disk. I'm like, well, you don't have to. But if writing to disk is important, don't use those products. If you're writing to disk and you're doing something that's based on HTTP, you might want to rethink that, because at the end of the day, HTTP is in fact stateless, and writing to disk is preserving state. So, make sure that you've reconciled those contradictions in your head. App Engine Flex. This is our, yes, we can run containers, any container you want, in a managed fashion. We support all of our official languages, all 7 of them. Let's see if I can name the 7 dwarves. Java, Python, Go, PHP, Node, .NET, and Ruby. But you can also run anything you can run in a container on this. Last year at this event, one of my colleagues ran Perl in a container as part of his talk. So really, truly, on App Engine Flex, you can run anything as long as you can put it in a container. Google Kubernetes Engine, yes, you can run anything there if you can run it in a container. And Google Compute Engine, if you can run it on your Lappy, you can run it on Compute Engine, mostly, almost always. And there's probably some things you can do on Compute Engine that you can't do on your Lappy, because your Lappy, fits in your bag, and you can make a really big machine on Compute Engine. So, 4th question, what is the happy path? Who's heard the term happy path before? It's one of my favorites. So, happy path is the thing that you want people to be doing on your website. So, if you sell stuff, that's the path where you sell them things, because that's how you make money and that's how your website keeps going. If you've got some sort of social media thing, you probably want people to log in and view a feed and talk to their friends. The happy path, if you've heard the 80-20 rule, is the 80 case. This is the stuff that goes on most of the time. Your I forgot my password link is not the happy path. It's important, but it is not the happy path. It's not where people are spending most of their time. And once you know what your happy path is, you need to instrument the heck out of it. First thing, minimum bar. You should have uptime checks. You should make sure that you know if the site goes down. Because if you don't, you're going to get angry customers or angry marketing folks. Don't do that. Stackdriver monitoring has uptime checks. Down at the disruption detector, we're showing that you can see your uptime checks in real time with latency from all over the globe. Uptime checks are awesome, but they're boring. The next thing you should do is you should monitor the performance of the happy path. This is where people are going to spend most of their time, so this is the stuff that needs to be fast and consistent. We have Stackdriver APM, which is Stackdriver Application Performance Monitoring, if you've never heard the APM acronym before. My favorite part of that is Stackdriver Trace. It's distributed tracing, it works across microservices, and it gives you a nice visual, timeline-y representation of what's going on with your app. I've been doing this long enough that I actually wrote one of these out on graph paper with crayons at one of my previous jobs to prove that we were fine, we didn't need more servers. But it's so much better when the computer draws the graphic for you. I really like Trace because it helps me see things like n+1 query errors. This is a really common error that you see in things like Django and Rails, where you have a loop, and inside the loop, you're doing a query to get a single row. So every time you go through that loop, you do a query. And it's much more performant to do the query ahead of time, pull back all the data, and then iterate through it, because queries have I/O implications, and they take longer. And I have written apps, on Google Cloud Platform that had this, and in Trace, it's like really obvious, because it's MySQL, it's Cloud SQL, Cloud SQL, Cloud SQL. Oh, I should not do that. We also have Stackdriver Profiler. It's relatively new. Everyone who's using it loves it. It's another way to see potential performance problems in your application. Metrics. So when I worked at the startup, we actually had a cash register sound that played in the office every time we made a sale. We were new. It was exciting. And every time we had to do a refund, we played the sound backwards. That was a metric. There are all kinds of metrics. Maybe it's simultaneous users, or number of successful logins, or number of times someone has gone through your checkout path. There's all sorts of metrics. Depending on your app, there's ones that are interesting or not to you. Nice thing about Stackdriver is that you can take those metrics out of your logs, because there's a lot of stuff you can't actually pull out of system data, but it's all over the logs. And you can make those log messages show up in aggregated form, averages, means, counts, in your dashboards as metrics. And then you can do alerts on them. So that's super cool. It's one of my favorite things about Stackdriver right now. And then there's SLA monitoring. We talked about it a bit in one of the keynotes. There's one other talks about it. We have a blog post we published last week on this. To do SLA monitoring correctly, you need to know what your SLA is. So if you have a team, you should sit down with your team. You should talk about your happy path. And you should talk about what is a reasonable amount of time that those requests should be taking. This is a very uncomfortable conversation. I recommend starting with the data you already have and decide, is this OK? If it's OK, you should just make sure that you know if it gets worse. If it's not OK, well, you need to put stuff in your work queue to fix it. And then you should make sure that you know if you're getting worse. One of the places I worked, we just had a stoplight. We had 5 requests that were I think they made up 98% of our traffic. And we had a stoplight because we knew we wanted the 95% case on all of those to be within a certain range. And if it went outside, the stoplight turned red, and that was bad. Question 5. So what are the rough spots of your application? So some of you are thinking, I don't write code that has rough spots. And I'm thinking, awesome, can I be you? Because I write code that has rough spots all the time. There are going to be spots where you didn't get as much QA coverage. Maybe it was really hard to test it. Maybe it's a third-party integration. Maybe you hate automated testing frameworks and you know that you just didn't get to it. Maybe there's that one person on your team who's like, my code is perfect. I shouldn't have to test. I'm not going to follow the rules. Great. We all have rough spots. Google has rough spots. Everyone has rough spots. Just know what they are, because you want to treat them differently when you're going to production. You want to instrument them. So one of the things I am very passionate about, there's a couple things in this talk, but this is one of my favorites, is you should know what the rates of 5xx and 4xx errors are compared to your 200s and your 300s. Here's why you should know that. I have found very many is not correct English. I have found a lot of production bugs using this. My 2 favorites are, I was working at a company, and marketing sent out a marketing email with a deep link to the website. Problem is we hadn't implemented that deep link yet. So all of a sudden, our 404 rate spiked. We had instrumentation on it. We had alerts on it. We're like, something is not quite right here. Let's go fix that. And we were able to really quickly shove a redirect in to make it so that all those people who had received that marketing message, after the first 50 or so, got to the right place. They didn't just see a 404 and think, well, those guys are dumb. Another story, I was working in consulting, and we were doing a project for a company, and we had just brought it online for the first time. And someone at our contact at the company hadn't told the IT department that we were doing this. So the IT guy or gal sees a thing on the network they hadn't done before, so they do the logical thing, and they start probing it, trying to figure out if it's secure. right? Totally makes sense. And we're sitting there going, what are people doing to our application? Because the 404s, the 500s, all the errors start spiking through the roof. And so we do the exact right thing you should do when someone's trying to find vulnerabilities in your website, which is we blocked that IP address. And then we get a call saying, why did you guys block the IT department's IP address? Because they were doing mean things to our application. But then we were able to figure out a time when they could do the security scan, when we knew that they were doing the security scan and it wasn't going to affect development. So, communication. But if that had been someone from the big, wide, scary internet, blocking their IP address would have been the right thing to do, and we only knew about it because we had this kind of monitoring in place. Trace and debugger, 2 features in Stackdriver. I've talked a little bit about trace. Again, it will help you find your errors. Debugger is the coolest thing we have. I am so stoked about it. If you haven't played with it, Stackdriver Debugger is live application debugging in production. You install an agent, it sits in the background, doesn't add a lot of latency or any latency depending on the language, and it does nothing. And then you're like, how the heck did that person get into that section of the if? I don't know, that's not supposed to happen. And you're like, great, Stackdriver Debugger. You go into the UI, you can either run it completely locally or you can hook your cloud repo up to it. Shows you your code, you hit a little button, you're like, tell me what the state of the application is when someone gets here. And a request goes through, maybe from you, maybe from a customer, and what we do is we capture the call stack, all the local variables, all the information that you probably need to debug it, and we print it out for you, and then we let the request finish. We don't give you step-through debugging, because that would be a horrible experience for whoever is on the other end of that request. But we do give you a good-sized watch window and a set of information about it. And a feature we added in the last couple months, maybe year, is we have a very small logging language that you can add arbitrary log lines to an application that is running in production. And the reason this is cool is you don't have to redeploy. You can do it all live. You can do it all in the UI. You don't actually have to push new code. And for anyone who's had to instrument a bunch of code and then push it and then had all of those log lines or whatever affect all your requests, this is magic. And I'm going to take a drink of water, and some of you should just think about what we had to do to make that work for compiled languages like Java and Go, because it's gross. Like, the day I'm like, wait, we have this for Java? How did we do that? And then they told me, and I'm like, yep, that's gross. And a lot of the libraries that do this are actually open source, so you can go look and see how we do it. Like for Ruby, this was not scary to me. Of course, we rewrote classes at runtime. We do that stuff. It's fine. And the other thing you should do on your rough bits is you should make sure that you shorten your release cycle as much as possible. I've been debugging a lot of stuff the last 2 weeks, and if I have to wait 15 minutes to figure out if my change worked, it is a bad day for me. So we talked about cloud builds in one of the keynotes. It is my new favoriteest thing ever. You're like, here's a bunch of steps. Go do that on really big machines, Google, and then put the stuff that you build or make somewhere where I can grab it later that's on your network, so it's on the same network as my production hardware, so I don't have to deal with latency. It's fantastic. There's a limited set of stuff that's already pre-configured for cloud build, but watch this space. There's going to be more and more templates and examples coming from both the community and from Google over the next several months, maybe years. I work on the languages effort specifically in advocacy, and a bunch of us are trying to figure out what the right templates to give our language communities are. App Engine Standard has a relatively short release cycle. You're like, please make this new code go here. That's great, use that. And Cloud Functions, again, I said it's one of my new favoriteest things. I've been debugging some really gross Cloud Functions because I'm not a particularly good JavaScript developer. And the fact that I can edit it in the UI, hit the, yeah, try that button, and it spins for, a minute, maybe 2, maybe only 30 seconds, and then there's a tab next to it that says test. And I click that, and it tries the function, and then the logs for that request spit out underneath it. It's great. I can iterate doing I can probably do 5 to 10 different attempts in an hour, maybe even more. It's fantastic. OK, so question 6. How fault tolerant am I? So this is the one that makes everyone really, really nervous and really, really not OK with the fact that I'm saying this. I'm going to tell you right now that you have to accept that sometimes things are going to go wrong. Maybe it's not your fault. Maybe a shark bit through the undersea cable. There is a story about that happening. You can go find it on the internet. But things that are bad are going to happen. So you have to acknowledge that things that are bad are going to happen, and you have to decide what you're willing to accept. If you've been to any of the SRE talks, you've probably heard about the idea of error budgets. I like error budgets. Error budgets are fantastic. Now, Maybe you work on an application that keeps airplanes flying and keeps people alive. Awesome, you're amazing. Your risk tolerance is going to be lower than mine. I make websites. It's fine if they go down for a little while. Nobody's going to die. So think about what your fault tolerance is. Maybe you can deal with an arbitrary or a reasonable amount of downtime outside of business hours, but you really need to stay up during business hours. Or maybe 15 minutes a month is all you can offer. But you need to know that so you can make the right decisions about how much capacity you need to provision, how much you need to monitor, and all that. Once you know how fault tolerant you are, you can work backwards and figure out what you should be monitoring. You should monitor as thoroughly as you need to make sure that you have achieved your fault tolerance goals. So, if you're not particularly worried, uptime's probably enough for you. But if performance is important to your fault tolerance, if you need to know that everything's working across data centers, if you need to know, latency on things, monitor the stuff. Monitor the stuff that can't fail, or monitor the stuff where you need to talk to someone if it does fail. If you don't take anything else from this talk, please take the next 2 points and write them millions of times until you get it. Don't wake yourself up if you can't do anything about it. Alerts must be actionable. My wonderful story about this was I carried the pager for a company for a couple years, and one night at 2 a.m. the pager goes off and heartbeat goes up, and the alert was the production disk on one of the 5 production servers is 86% full. Okay. And I go look at the alert history, and I'm like, oh, 5 days ago it was 85% full. I don't have to do anything about that at 2 a.m. There is nothing interesting happening. We could wait several more weeks, and it would be fine. So I should not have gotten woken up for that alert. That is an example of a bad alert. It was also an alert that I configured, so that's my own fault. But make sure that if you're alerting on something, that there is either something technological that you can do to fix it, or there is someone that you need to either be telling that something is going wrong or apologizing to. That is also an action. But if there's nothing that you would do in the middle of the night if this went off, if it can wait till the next morning, alert in an appropriate format. Also, alert on what needs to work. If you're okay with, your forgotten password link not working for a couple hours, that should not set your pager off. Focus on the stuff that's really important to work, and please ignore the rest, because pager fatigue is totally a thing, and it's horrible when you get it, and it makes everyone ignore everything that's going on, and then something bad happens, and everyone freaks out, and please don't. Your life will be better if you don't. I also like, when I'm setting up a site, have 2 dashboards. I have a dashboard for my happy path, my critical path, and then I have another dashboard that is the entire system holistically. And the reason I have this is someone comes running over to my desk and tells me that everything is on fire, and I'm like, oh, that is very interesting. And then I look up at my 2 dashboards, and if the happy path dashboard is all red and scary, yes, everything is on fire, and I should probably work on that right now. But if the holistic dashboard is red and scary, but the happy path is not red and scary, I probably have a little bit of time before stuff goes really sideways, so I can take a deep breath and gather my thoughts and get to a place where I can actually deal with this in an appropriate fashion. I find it really helps for me to separate, is everything on fire, or is only the really important stuff on fire? Or is, the thing that's on fire interesting, because I like when stuff breaks, it's cool, and but not so urgent. So I'm going to talk about disaster recovery. I'm not going to give you a ton of information on this. Go read stuff. I'm going to tell you that all the SREs I know would tell you should be in multiple regions or zones, pretty please. It's better for you. It's better for everyone. Please make sure that you can deploy in multiple regions or zones. You don't have to have them both live. If you don't deploy in multiple regions or zones, make sure that you can deploy to a new region or zone relatively quickly if being up relatively quickly is important. Google had an outage last week. It was a global outage, but lots of other cloud providers, including us, have had regional outages before. A good way to protect yourself against those is to be in multiple regions or zones. It's also, if redundancy is really important to you, if robustness is really important to you, pick one of the options that's self-healing. Most of our things can be self-healing if you configure them to be that way. I love Kubernetes because I can just delete VMs underneath it, and it's oh, there's a VM that is deleted. Let me please create a new one. It's just chill about it. It's great. I also, if you're going to do multiple regions, one of my biggest pet peeves about other systems that I've used is that you can only see one region at a time on your screen. I really like that GCP, this is my only marketing thing here, I really like that GCP shows you everything. You saw in the keynote on Tuesday when they showed the Kubernetes on-prem that you could see 2 different clusters at the same time in different regions. I can't tell you the number of times I have lost a VM because I created it in a region that I'm not currently looking at in other providers. And then disaster recovery is complete lie unless you practice it. I deleted a production database at midnight, and the only reason that I did not completely freak out and lose my brain was that I had practiced restoring a backup on my local machine multiple times. I had done it on a staging machine. So I took a deep breath, got myself a glass of tea, and started the restore, and then emailed my boss and said, sorry, we're going to be out for a while. I should have it back up by, one, maybe two. So the last thing I have on my list of questions, and this is the one that everyone messes up. Where are my secrets? Everyone's got secrets. Secrets might be things like service account keys. It may be API keys for third-party services. And the big one is user info. Hi, I am likely to be a user of at least one of your guys' products at one point. Please don't leak my data. I would very much appreciate that. So where do secrets end up? Secrets end up at all sorts of awesome places. Secrets end up in source control. I have checked in a GCP service account key before. Yes, once you have done that, you need to provision a new key and delete that and never use it again. You have just shared it with the entire internet. It's a password. We don't share those. Secrets frequently end up on development and build servers, and you're like, well, that's OK. Except I worked at a company where we had one of our dev boxes stolen. Someone stole it on a subway or something. And if we had had any user info or any API keys on that machine, they would have been immediately compromised. So try not to let secrets get on dev boxes. It is a really bad idea. The one that happens a lot, and has happened recently to a relatively large tech company, is that secrets end up in logs. Frequently, this is personal information. So think about it this way. Someone submits a form. Do you log the post body? A lot of frameworks and applications do by default. Anything in that post body is now likely in plain text in your logs. So my password, my credit card, my address, all of that may have just been dumped to your logs. No, we don't do that. I have done it. I felt very guilty about it, and we fixed it within an hour. It was a long time ago, like 15 years ago. The same thing with alerts. If you have a 500 error, do you take a whole entire snapshot of the request and then throw that in the alert that you're sending out to the person on call? Again, that's probably got some stuff in it that you shouldn't be doing that with. Because if you're sending it out to an alerting system, you're automatically sharing all that info with whatever the alerting system is. Think about it. I'm not saying you shouldn't do it, but make sure you're doing it consciously. Email, I worked at a company where we emailed every piece of user feedback to every employee at the company. No, that's a bad idea as well. We ended up running it through an anonymizer and then doing it, which was actually quite awesome, because some of the feedback was great. And then databases. You're like, well, of course personal information ends up in databases. Please see my comment about dev boxes getting stolen. If you let people install a production copy on their local machine, make sure that everything in there is anonymized. Ideally, you would have a separate database of test info that they could use for testing. So how do you protect your secrets? There's some stuff that you just have to do in your engineering practices. They have to be done on the application layer. I'm sorry, we don't have magic stuff for that yet. I am sure they will come up with something soon. They seem to come up with magic stuff all the time. But we do have the metadata service and Kubernetes secrets APIs. Metadata service is one of my favorite things about GCP. I can say, here, put this SSH key on all of my boxes. Oh, that guy left. Take that SSH key off of all of my boxes. And I don't have to reprovision machines. Especially when I was consulting, we were constantly reprovisioning machines as people cycled on and off the project. You can also use the CLI. I like using the web interface because I'm lazy. Kubernetes secrets is a little confusing. There's a lot of people who have opinions about it. But I've talked to enough of those people now that I actually believe the way they're doing it is good. There's a couple ways to do it. The way I like doing it is you set up some secrets, and then you can access those. There's different ways that you get access to that information. You can do environment variables, or you can also have them mounted as a file system that you can then pull from as part of your container. There's a couple ways to do it. It's great. Just take a deep breath if you're like, this is the weirdest way to do this. They've thought about it a lot. This is one of the few times I will say, give them a shot. You don't have to agree, but at least try it. So I told you we were going to have a review at the end. Compute. Cloud functions. You can use JavaScript. JavaScript is awesome. Python is coming soon. It scales from 0 to lots and lots and lots. I believe that is a technical term. I really like the speedy deployment cycle on this one. And if you can get into the small functions, lots of people working on small pieces thing, it's great. Some people can't get their heads around it. It took me a while, but I think I'm there now. Compute engine. It's a VM. It can run stuff you run on a computer. You can make it whatever size and shape you want. We have sliders for that. If you're going to do this, check out managed instance groups. They have health checks that you can use. If you use the health checks, you can get self-healing, and you can also get auto-scaling. And so you get all the kind of niceties that people talk about of some of the managed services, but you just have it on a VM. VMs are familiar to many of us. We know how to make a VM work. It's awesome. And it's cheaper, but it might need more of your time to handle it or set up provisioning scripts in something like Puppet, Chef, or Ansible. App Engine, we have 2 flavors, standard and flexible. It's really easy to deploy. You type gcloud app deploy, and if it's one of the languages we know, we say, it looks like you're running blah. Would you like us to write a configuration file for that? It supports all languages in some form, and it supports anything you can run in a container on Flex. App Engine Standard scales down to 0, so anything that runs on App Engine Standards you can scale down to 0. But it has restrictions on what libraries you can use. Logging, error reporting, and basic monitoring come by default with App Engine Standard, and they're very easy to set up for App Engine Flex. And it does a load balancing and networking for you. My least favorite part of running on VMs is setting up networking. And so if someone else does that, that's great. Kubernetes Engine. It runs containers. I'm supposed to have a picture of a container ship or something on this slide, but it does auto-scaling and self-healing. It can't scale down to 0, but it can scale down to not very much. There are no restrictions on what you can run as long as you can put it in a container. And it does the load balancing and networking for you. So I actually end up running a lot of stuff in Kubernetes Engine because I get to run whatever I want in whatever way I want. And it does service discovery for me, and I don't have to set up load balancing and networking. It's fantastic. Stackdriver, the other main thing I talked about today. This is our operations, monitoring, logging, debugging. It helps you make stuff better and know what's going on platform. Stackdriver monitoring, alerting me of any different means. You can get emails, you can get something dumped into PagerDuty or into one of your team chat apps. You can set up custom dashboards. You have system-level monitoring, so how much CPU am I using? How many bytes are going over the wire? But also application-level monitoring. What's my ratio of errors? What's my average latency? What's the latency of the 95% case? Because we all know that if you just look at the mean, that one request that took 5 minutes is just going to break everything. It's multi-cloud. You can use it on AWS and GCP. And for a lot of the features, you can actually use that on-prem or anywhere you can run your stuff if you install the libraries. If you're going to do this, remember, alerts should be actionable. And you should probably set up something that vaguely looks like a system overview so you can quickly know what the heck is going on. Stackdriver logging, log aggregation. You can search stuff, pretty good query language. You can export to files, or you can export to BigQuery, which is really super crazy powerful. You can feed the logs into metrics and monitoring. I talked about that earlier. Again, multi-cloud, use our libraries. You can also use it on-prem if you use our libraries. Tips, handle your secrets with care. Please don't dump secrets to logs unless you can control access to those very, very well. Trace. This is the tracing through microservices thing. This lets you kind of see the timeline of what's going on in your application. It also has cool features like period-over-period performance. So someone's like, the website is slower this week. And you can say, no. I can impose a latency graph over top from last week and this week, and the answer to that is no. Or you can say, oh, yeah, sorry about that. I'll fix it. You can also debug bottlenecks and timeouts quickly. For some sets of errors, we may actually predict what the problem is and say, hey, you might consider adding an index here. But you need to instrument your app unless you're running on App Engine Standard. And the recommended agent's going to be different depending on your language. For some, we're using OpenCensus. For some, we're using Stackdriver trace agents. I believe we're moving in the direction of OpenCensus for everything. Stackdriver debugger, this is the live production debugging. Please go try this. No one believes me, and it is amazing. But again, you need to instrument your app with the agent. A lot of people get a little twitchy about that, like, well, why should I have this running in the background? You should have it running in the background so that when something goes wrong, you don't have to do another release cycle to debug it. And then Stackdriver error reporting is crash aggregation. Something broke. It groups all the stuff that's vaguely similar. It takes representative traces. It can link you to the logs. It can link to your bug tracker. So you can kind of say, you can start from something is wrong, and then look at all the other tools that are all linked together to debug it. If you've ever had to assemble a performance monitoring, regular monitoring, log aggregation tool from a bunch of different toolkits, having everything talk to each other is really, really nice and saves a lot of time. It has alert backoff built in, so if you do something really stupid and you're getting a lot of alerts, you won't actually have your Pocket explode on you every time someone hits the path that's broken. And it's automatically set up for App Engine Standard. It's really easy to set up for App Engine Flex. You just grab the library and you shove it in your app. Stackdriver Profiler. People are super into this. It helps you improve code performance, so that's probably why they're into it. It's also really easy to use and uses flame graphs that people are used to. We have it for Java, Go, and Node right now. I would assume more is coming. I can't actually give you a timeline on that. And that's what I have. Thank you for coming. I know it's the end of the second day, and this is a giant, crazy conference and very overwhelming. I appreciate your time. Again, I'm Aja. I'm on the application development advocacy team. So I am not an ops person, but I'm happy to answer any of your questions. You can email me at Thagamizer, which is spelled exactly how it sounds, at google.com, or you can tweet at me, _Thagamizer. And I have a couple minutes at the end after I'm talking to hand out some stickers to people, but I actually have an appointment very shortly. So thank you very much. I appreciate your attention.